linear velocity, and then angular velocity. Now, linear velocity is defined to be denoted by v for velocity, is defined to be the distance traveled divided by time. So just a regular velocity definition that we had before. But this time we apply that on a circle. Let's see if I get a circle. And now linear velocity refers to the distance traveled along the curve, the distance traveled here, the distance traveled here, along this curve here, over time. So in the past, we call this S for the distance, right? The arc length. Now, so the linear velocity that we will use here is the arc length traveled over the time t. Now, and in contrast, angular velocity usually denoted by omega, looks like a W, is defined to be the angle traveled over the time. Now, of course, the theta here, don't forget the theta here has to be in radian. And that's it. That's the only two formulas you need to memorize from this section. The rest, let's apply these formulas. For example, I hope you have your textbook with you. Don't forget you need to return your book after you're done with this class, okay? Maybe in the fall. For example, we look at page 149. Let's say we do number 4. Number 4, we have the distance traveled to be 12 centimeter, and the time is 2 seconds. The question is, find the linear velocity. The linear velocity will be 12 centimeter, the distance, right, divided by the time, 2 seconds. That will give us 6 centimeter per second. Just like that. Furthermore, let's see, for example, we have number 8. Suppose we have the linear velocity to be 10 feet per second, and the time to be 4 seconds. Now then we use the formula E equals to S over T to solve for the distance traveled. Actually, I multiply both sides by T. I get the distance traveled is velocity times time. Now let me ask you to do this first. I have an important call coming in. Okay. Once you're done with that, you can try number 12. Okay. So S equals to 45th. Number 12. Thank you. Okay, number 12, we have the velocity, linear velocity, be 63 miles per hour. However, the time is only 10 seconds. Here we need to be a bit careful. The velocity equals to the distance over time, such that the distance is velocity times time, right? But the thing is, the units are not the same. One of them in hour, the other one in seconds. So I need to change either into hours or into seconds. Let me change into hours then. Now, how to convert seconds to hours? 1 hour, how many seconds? 1 hour, how many seconds?
60.
Huh? 60 minutes.
Oh,
Right? And each minute we have 60 seconds. So in 1 hour, there are 3,600 seconds. Oops, sorry. Which, if I simplify, I get 1 over 360 hours. Now, that's the number I will use in my formula. Basically, the units has to be the same. Okay, that's miles per hour. This also in hours. Now, then the distance will be 63 miles per hour times 1 over 360 hour. That's the distance traveled. The hours cancels. The hours cancel. So we get 63 over 360 miles. That's the distance traveled. Now, of course, I believe I can reduce this by at least by 9. If I reduce by 9, this is 7 over 40 miles. That's the distance traveled. Okay, let me go on. Another example. Number 14, let's say. The question is, point P sweeps out central angle theta and with radius r. Number 14, theta equals to 3 pi over 4. Now notice that they don't use degrees, so it must be in radian. Okay, while the time is 5 seconds. Oh, hold on, give me a second. Oh, I think I know what happened. Okay, sorry. The time is 5 seconds. So what is the angular speed? the angular speed will then be theta over t, which is 3 pi over 4 big over 5. That will be 3 pi over 4 multiplied by 1/5. When we divide by 5, we multiply by the reciprocal. I hope you remember that. And this will be 3 pi over 20. Now, what is the unit? The unit will be radian per second. Well, because even though they don't tell us the unit, implicitly this is in radian. Okay. Number 24. Omega equals to 2 radian per second. Omega equals to 2 radian per second. And then the radius is 2 inches. And the t is 5 seconds. The question is, find the distance. Now we know that linear velocity equals to the distance over t, right? So the distance that we are looking for is the linear velocity times the time t. Now, however, we also know that the phi omega is equals to theta over t, right? Now, what I try to connect is the following. I want you to realize that S at the same time over t, S over r equals to theta. Now, I will put these formulas together. Okay, so if I put it here, oops, what happened? If I put it here, then you will see omega equals to S over RT. Therefore, the distance equals to omega times R times T. Now, this is another formula you need to remember. But this formula is basically the combinations of those formulas that we have before. Okay, maybe I give you another formula that may be useful. That is linear velocity is equal to the angular velocity times r. If you wonder why, v equals to s over t, but s is the same to theta r. Okay, now then theta over t is omega. So v equals to omega r. Okay, so that's another formula we need to memorize, that the angular velocity is equals to, linear velocity is equal to angular velocity times the radius. Now, let's go back here. How to find this s? According to the formula we have, s is equal to angular velocity times the radius times time, which is 2 radian per second times 2 inches times 5 seconds. the seconds cancel. So I get 20 inches. That's the distance traveled. Sorry with my disorganization here. Maybe I erase these. Move it. Let's move it here. Okay, so that's a new formula. Besides those two formulas that we have before, that is the phi equals to S over T and omega equals to theta over T. Okay, now these are 4 formulas you need to memorize from this section. Let's do another one, or you do it. Let me ask you to try number 28. Number 28, omega equals to 10 radian per second. The R is 6 feet, yet the time is 2 minutes. Notice that the units are different here. So you need to first change this into how many seconds. By the way, 2 minutes, how many seconds?
120 seconds?
120 seconds, that's right. Then plug this into the formula that the distance traveled is omega times R times T. That's 10 radian per second times 60 feet times 120 seconds. What will that be? That's right, that will be 7,200 feet. Okay, now let's go on further to, oh, you know what? What about RPM? What does RPM stand for? RPM stands for revolutions per minute. Now, one revolution means 1 circle. This means 1 circle. Now, 1 circle is how many radian? One circle is how many radian?
2 pi?
That's 2 pi, that's right. So one revolution per minute basically means 1 RPM means 2 pi radian per minute. Okay, now the thing is both of them use R, both of them start with R for revolutions and radian. right? Such that there's a big chance that you misunderstand the radian and revolutions, but they are actually different, okay? They are actually different. Now, with that in mind, then we can go on doing more problem from this section. Let's say, for example, we do what's good, number 36. Number 36, find the linear velocity if the radius is 8 inches and the angular velocity is 4 radian per second. Now we know that linear velocity equals to angular velocity times the radius. So I plug in numbers here, 4 radian per second times 8 inches. That will give me 32 inches per second. Number 40. Find the phi, the linear velocity, if the radius is 1 foot and the omega. The point rotates at 20 RPM. Now 20 RPM means 20 times 2 pi radian per minute. So what is the linear velocity? The linear velocity will be omega times r, which is 40 pi radian per minute times 1 foot. That will be 40 pi feet per minute. Okay. Now, suggested homework from this section will be 3.5, number 1 to number 21, and then actually let's go ahead to number 43, up to number 43. Okay, that's for this section. And if you have a chance, I usually ask questions from the bicycle. So try to read, also read page 153 on the cycling. Maybe on Wednesday, when we come back, we will do some problem for, we will do number 55, 56, and 57, or maybe on, okay? But there you need to kind of like imagine a bicycle where they have the rear wheel, and we have the sprocket. I'm sorry, this is the sprocket here. This is the sprocket. And then we have chain ring. This is the chain. Now then, when we do pedaling, the pedal will be here. when we do paddling, the speed, the angular velocity of my paddling will be the same to the angular velocity of this thing here, the chain ring. Okay, so let me write it down. The angular velocity of the paddle is equals to the angular velocity of the chain ring. Now, however, between this chain ring and sprocket, what will be the same? It will be the linear velocity. Linear velocity of the chain ring will be equal to the linear velocity of the sprocket. Now then the angular velocity of the sprocket is the same to the angular velocity of the rear wheel. Okay, now then what we will try to do later on is to find if we know the angular velocity of the paddling, then how fast will with the bicyclist, the cyclist actually cycling. That's what we will do on Wednesday, but that's actually something you can do easily. I can just quote a problem from my old test later on. Okay, now what I will do next is actually to work on 4.1. We will start doing graphing. On this 4.1, I would like you to do me this favor. The first thing we will do here is we will graph, so 4.1 basic graph of trig functions. And we will first focus on the graph of, we'll focus on the graph of y equals to sine x. Sine x. Now, how do I want you to do this? I will first ask you to create a table. Give me a second. I need to draw a line. I would like you to create a table of the angle and the value. So basically, when the theta equals to 0, when the angle is 0, what is sine 0? When the angle is 30 degrees, what is the value of sine 30 degrees? Anybody listening to me?
Yes.
Okay.
Yes.
Sine 30 degrees in decimal is 0.5. Sine 45 degrees is 0.707. Just make it 0.771. sine 60 degrees is 0.866, as I remember. Let's make it 0.87. And then sine 90 degrees is 1. Now, what I want you to do is to continue with 120 degrees, 135 degrees, 150 degrees, 180 degrees. And then go on even further, 210, 225, 240 degrees, 207 degrees. And even further, 300 degrees, 315 degrees, and 330. Now let me ask you use your calculator and to get the value of this. I will give you maybe 2 minutes or 3 minutes, maybe 2 minutes from now. And then later on we will plot this this graph. Oh, by the way, before I forget, I would like you to also, if you happen to have time, also write the corresponding angles in radian. Like this one is 0, pi over 6, pi over 4, pi over 3, pi over 2, and on. Okay, let me give you, let's say I give you 5 minutes. I hope we are done, and let's see what you have for the value. 120, this is, sine 120 is radical 3 over 2, that's 0.87. Sine 135 is radical 2 over 2, 0.71. Sine 150 degrees is 1/2, and this is 0. Now we start the negative value, negative 0.5. Negative 0.71, negative 0.87, negative 1, and then negative 0.87, negative 0.71, negative 0.5. While I ask you to check, let me also write this down. In radian, what are these? What these are? 300 degrees is 5 pi over 3, 7 pi over 4 for 315 degrees, and 330 degrees is 11 pi over 12. Do you have this already? Nobody say anything. Okay, I hope you already have this. Now, what I will do is I will plot these coordinates on a graphing paper. I will plot this coordinate on the graphing paper. Let me see where did I put it here. Do you see my graphing paper here?
Yes.
Yes.
Okay. The thing is, I need to, how do I put this there? A second, I need to think about how to put this there. open it as a PDF file. Give me a second, okay? While I try to upload my download. I have hard time to copy some file into here. Give me a second, okay? How do I do that? Uh, you see this now? I wonder what you see. Oh yeah, you are at this page here. Do you see this graphing paper?
Yes, we do.
Yes, I see it.
Okay, now I will start with, I will try to graph this, the sine graph. Now, this will be my x-axis, and this will be my y-axis. Now, the angles will be 0 degree here, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Now, I make these graphing papers on the x component for the x-axis is multiple of 15 degrees. So from here to here is 15 degrees, another 15 degrees, 15 degrees, so on and so forth. Now, how about the y values? The y's values, this will be positive 1. This is 0 0.4, 0 0.6, 0 0.8, 0 0.2. So I make it that from y equals 0, this is 1 unit, and going down likewise, every one grid is 0 0.2. Now I will start graphing this. What is sine 0? Sine 0 degree is 0. How about sine 30 degrees? 0 0.5. Sine 45 degrees, 0 0.71 approximately here. Right? If you see 0 0.71 is approximately 0 0.7, is between 0 0.6 and 0 0.68. Okay? So sine 45 degrees, approximately 0 0.7. How about sine 60 degree? Almost 0 0.9. And sine 90 degrees is 1. Likewise, I go on, sine 120 degrees is 0 0.89. Sine 135 degrees, approximately 0 0.7. Sine 150 degrees is 0 0.5. And sine 180 degrees is 0. Now, if I connect the dots here, I will get this graph. Oops, sorry. We'll get this graph. Okay. And then the one here will be down to 0. So approximately that's the sine graph. I don't like this graph. Now, if we go on to the third and fourth quadrant, this is 210, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330 degrees, and 360 degrees, and we will get sine 120 degrees is -1/2. Sine 225 degrees approximately 0.7. Sine 240 degrees approximately almost 0.9. And sine 270 degrees is -1. So if I continue from here in the third quadrant, it looks like this, and so on and so forth. So the graph of sine will be something looks like this. This is the graph of sine. Now, here's what I want to do. Everybody, are you with me?
Yes.
Okay. Now, I would like you to go to the discussion main page, the discussion for the day here. And I would like you to try to print this file out. Try to print this file out and do what I did just now. Now, what happens if you don't have a printer? Then you basically see again what I did earlier. Okay, but on the discussion, you can print this sine graph. Okay, and if you don't have the graphing paper, then try to take a look again here. Now, what my plan is this. If you have a chance to print that out, I would like you to later on work on the graph for cosine. This is the graph for y equals to sine x. This is the graph for y equals to sine x. I will give ourselves some little break. Right now it's 8:29. We come back at 8:40. We come back at 8:40. Back at 8:40. Okay. So let's take our break. At the same time, if you can, if possible, please print that graphing paper out. Otherwise, then try to see again what I did earlier. See you in 10 minutes.
Okay.
Got it.
Okay, let's start again. We already have the graph for sine x. I would like to summarize it at least this way for the purpose of our lesson later on. Where's the, okay. Later on, I will ask you to put this sine graph into a 2x4 column. Sorry. I don't like that. Give me a second. It's not right in the middle, that's the thing. So the graph of sine graph later on will be approximately like this. This is in quadrant 1, and then in quadrant 2, and then quadrant 3, and then quadrant 4. Okay, where the center is 0, maximum is 1, minimum is -1. And the sine graph will go one cycle at 360 degrees or 2 pi. So the first quadrant will be from 0 to pi over 2, second quadrant from pi over 2 to pi, the third quadrant from pi to 3 pi over 2. Now this is the graph of sine graph if we summarize from the detailed one we have above. From the detailed one we have above here, I will summarize it to be like this. Now I call this 2 by 4 columns because there are 2 rows and 4 columns. Now that's for the sine graph. Let's go on to do the graph for cosine. Now for us to do the graph of cosine, I would like you to do something similar to what we did earlier. So when x equals to 0 degrees, what is cosine x? And so on and so forth, 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. That's for quadrant 1. For quadrant 2, 120 degrees, 135 degrees, 150 degrees, 180 degrees. And then quadrant 3, 210 degrees, 225 degrees, 240 degrees, 270 degrees. And furthermore, the last quadrant, 300 degrees, 315 degrees, and 330 degrees. Now let me give you 5 minutes. Let me give you 5 minutes from now to get the values here. Just use your calculator. You will see that the numbers actually the same numbers we had earlier with the sine, but it's kind of like being in different order. For example, cosine 0 degrees is 1, cosine 30 degrees is 0.87, cosine 45 degrees 0.71, cosine 60 degrees is 0.5, cosine 90 degrees is 0. Now I want you to go on further, finish this into 360 degrees, and then put it into the graph if you happen to have that, if you can print that out, this thing. Okay, but let me ask you to do this first, fill it up, and then later on we work on this. This is 0, the maximum is 1, the minimum is -1. Okay, at least do this table first here, and if possible, do that this details cosine graph. I give you 5 minutes. Let me continue. This will be negative 0.5, negative 0.71, negative 0.87, negative 1, negative 0.87, negative 0.71, negative 0.50, and then 0.5, 0.71, 0.87, and go back to 1. Now then, when I plot this, let me do the angles first. 120 degrees, 135 degrees, 150 degrees, 180 degrees, 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330 degrees, 360 degrees. Now, then this is 0.2, 0.4, 0.6, 0.8, negative 0.2, negative 0.4, negative 0.6, negative 0.8. And cosine start from, cosine 0 is 1, cosine 30 degrees is 0.87, almost 0.9. Almost 0.9. And cosine 45 degrees, 0.71. I get the note. And then cosine 60 degrees, 0.5. Cosine 90 degrees is 0. Cosine 120 degrees is negative 0.5. Cosine 135 degrees, negative 0.71. Cosine 150 degrees is almost 0, negative 0.9. So if I connect the dots here, it will be approximately something looks like this. And if I go on there, it will be approximately like this. This is the graph of y equals to cosine x. If I summarize this graph into 2x4 columns, this is just approximate. Then I will start from 1, going down in the first quadrant. It should be curved either. And then in the second quadrant, it's negative value. The third quadrant, it's still negative. The fourth quadrant, it is positive. The minimum is negative 1. Start from 0 to pi over 2, pi, 3 pi over 2, and 2 pi. Now, let's see what we have for this cosine graph here. Important things to remember. The first one, the center is 0, which means the graph is actually goes up and down around x equals to 0. Okay? It actually goes up and down around x equals to 0. The maximum value for cosine x is 1. the minimum value of cosine x is -1. Actually, then from here we see it's -1. From here we see that the range of cosine, whatever value of x you plug in, the value of cosine will be in the interval of -1 up to 1. So cosine anything cannot be 2. Cosine anything cannot be -3. No, it has to be between -1 to 1 only. Okay, now we also see that this graph finished one period. This graph finished one period in 2 pi, one cycle in 2 pi. Okay, so once it finished 2 pi, it will start the same cycle again. We then say the period for cosine x is 2 pi. Now, because the maximum is 1 and the minimum is 1, which means it's actually fluctuating. It's fluctuating from 0, goes up 1, and goes down 1. Then we say the amplitude is 1. Now you can say the amplitude is 1 because from the center at most it goes up 1 and goes down 1. Now, let me ask you to look back to our sine x and answer this question. What is the center? I'm sorry. What's the amplitude? Once you know the center, what's the center here? If anybody listening, I feel like I'm talking by myself, but that's okay. We move around the center x equals to 0. I mean, y equals to 0. And from that center, y equals to 0, it goes at most 1 up, at most 1 down from the center. Therefore, we say the amplitude is 1. Now, therefore, the maximum will be 1, which actually coming from the center plus 1. And the minimum is the center minus the amplitude. Therefore, the range is from -1 to 1. You see that the informations we have here is actually the same to the ones for cosine. The center is 0, the amplitude is 1, therefore the range is from -1 to 1. Also, the period is is 2 pi, which means, again, it will repeat the same cycle every 2 pi. Use this, you see, from 0, it finished one cycle at 2 pi, right? So later on from here, if you continue, it will form the same cycle again, up and down again, like that, okay? And even if we go to the left, it will repeat the same cycle. Okay.
Sorry, Professor. What is the amplitude?
Amplitude is how far it goes up and down from the center.
Okay.
So if this is the center,
Mm-hmm.
which is y equals to 0, then how far it goes up? How far it goes up from the center? From the center, how far it goes down?
Okay.
That's how we get the amplitude is 1. Now,
Okay.
Give me a second. Now let me bring your attention to what the graph's supposed to look like when we put them on graphing softwares. This is the graphing softwares I have on my computer. I hope you see this. Now, the graph of sine x looks like this. You see that the graph is actually dancing around y equals to 0. Okay, the maximum. What is the maximum again?
The maximum is 1.
The maximum is 1. Right? You see the red color line? And the minimum is -1. Now, it repeats the cycle every 2 pi. So if I kind of zoom into this one cycle here, you see this is the graph of sine x. It starts from origin 0, 0, goes up to 1 at 90 degrees, goes down back to 0 at 180 degrees or pi, and then goes to -1 when x is 3 pi over 2, and so on. Now, the reason I show you this because on Wednesday, we will work on how this graph will actually move around. Now, this is the graph of sine x, right? Now then, let's compare to what happened if I have y equals to sine x, but then I add, let's say, 3. Now, if you are still fresh with your intermediate algebra, then you see that sine x plus 3, this graph here, is basically the graph of sine x move up 3 units. So from here, you move up 3 units. From here, you move up 3 units. From here, you move up 3 units. From everywhere, you move up 3 units. Now, so in other words, if I ask you, okay, sketch the graph of y equals to sine x plus 3. Y equals to sine x plus 3. Or we can also say 3 plus sine x. And I ask you to graph that on 2 by 4 columns. I do it fast because the time's almost up. Then the graph will still look the same. This is the graph of sine x, right? This is the graph of sine x. Okay, this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. Now, what changed is the 0, 1, and -1, it doesn't work anymore because we add 3. It becomes, if I add 3, it becomes 4. If I add 3, it becomes 3. If I add 3, it becomes 2. So if I do the same summary like earlier, what is the center for this graph?
3.
The center is 3. How about the amplitude?
4.
No,
No,
1.
1, right?
1, that's right. So because the center is 3, amplitude is 1, what will the maximum be?
4.
4, that's 3 plus 1, right? And the minimum will be
2.
2, that's center minus the amplitude. Okay, the period is still 2 pi. Okay, now let's go back to my graphing paper, my graphing software. What if I change, instead of sine x plus 3, I make it 2 sine x. Y equals to 2 sine x. Notice that the graph will still have the same period. It finished in 2 pi. If the green one finished in 2 pi, then the purple ones also finish one cycle in 2 pi's. The difference is in the amplitude. The amplitude of the original sine x is 1. From 0, it goes up 1, right? But once you put coefficient 2 in front of the sine, you stretch the graph vertically, becomes, instead of going up 1, it goes up 2 from the center. Instead of going down 1 in the sine x, now it becomes going down 2 from the center in 2 sine x. Okay, so having a coefficient in front of the sine graph, or later on you see the cosine graph, will stretch the graph vertically. Will stretch the graph vertically. Now, let's see. What is the amplitude again for sine 2x?
2.
2. What is the maximum?
2.
How about the minimum?
-2.
-2. So if I go back to my graph, my note, then we can say the following. For example, if I have y equals to, let's say, 3 sine x, then what's the center?
0.
Center is 0. How about the amplitude? From y equals to 0, how far it goes up and down?
3.
Goes up and down 3. Therefore, what is the maximum?
3.
How about the minimum?
-3.
-3. Therefore, the range will be
3, -3.
from -3 to +3 inclusive, including the endpoints. The period is still the same, 2 pi. Now then, if I graph that on that 2 by 4 column, then it will start from, it's still the regular sine graph, right? It's still the regular sine graph. Still like this. Okay? 0, pi over 2, pi, 3 pi over 2, and 2 pi. The thing is, the center is
0.
and the amplitude is 3, means from that 0 I goes up 3 units and goes down 3 units. Finally, in the last couple minutes, let's see this question. Y equals, for example, y equals to 2 plus 4 sine x. 2 plus 4 sine x. So it's basically the graph of sine x. We stretch vertically by a factor of 4. Therefore, the amplitude will becomes 4. And then we move up 2 units, which means the center now becomes 2. Center is what?
2.
The amplitude is
4.
4. We look at the coefficient of the trig functions. Therefore, the maximum will be from the center, you add the amplitude. And the minimum will be from the center, we subtract the amplitude. Okay, therefore the range is from -2 to 6. And then it's still the sine graph. So you see the graph, the shape of the graph stays the same all the time. The shape is the same, but we actually play with the scaling. The center is 2. I move up 4 units, becomes 6. From that 2, move down 4 units, it becomes -2. This is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, what is your suggested homework? I want you to read 4.1 and 4.2. 4.1, 4.2. We cover 4.1 already. We will do 4.2. And if possible, 4.3. Now, this is what I will do. You read these sections here, and I'm sorry. I think my acid reflux coming back. Tonight or tomorrow morning, I will post some lecture videos on the announcement. So you go to your campus and go to the announcement. Then I will give you some lecture videos from YouTube for you to watch, and hopefully it gives you some foundation to prepare you for this Wednesday class. Now on Wednesday, I will finish 4.1, 4.2, 4.3, and if possible, we also go over 4.4. Okay, if possible, we also do 4.4. I think that's all. I will post the PDF file of this note on the discussion. So the notes for today will be posted on the discussion for the day. And I hope within couple hours I can upload the recording, the video lectures, basically what you see throughout the day today. Okay then, see you on Wednesday. Oh, my office hour is from Monday, Wednesday is from 3 o'clock to 4:25. And then on Tuesday, Thursday is from 7 o'clock to 8 o'clock at night. And if you have question, send me an email first, and then I'll tell you the link to the Zoom that you can interact with me. But I think if you have question, you can just email me your question and your work, just like before. Okay, then see you on Wednesday.
All right. Thank you.
You are very welcome.